we think about lines that intersect. So if this is my xy axis, lines that intersect have one solution and are considered to be consistent and independent. If we have lines that are consistent and dependent, what we're thinking about is one line is a multiple of the other line. So for example, if I gave you x plus y equals 4 as one equation, if my second equation that I'm going to give you would be 2x plus 2y equals 8, would you see that they are exactly a multiple of the first line? So when I would try and graph the two lines, wouldn't one line fall directly on top of the second line because they are just, it's a repeat of the first line? And so then in that case, we have infinitely many solutions. Every solution on one line or every point on one line is going to be a point on the second line, correct? And so that's when we can say that it's consistent but dependent because they're all on top of each other. Does that make sense? All right. The last one is going to be, just has one word, which means inconsistent or no solution. When do we have an example of two lines that are never going to have a common solution? What do those two lines look like? Parallel lines, exactly. So when we see these, we think of lines that are parallel. Okay? Lines that are parallel. So for example, I might give you a line that said something like, hold on a second, let me look for one. If I said, for example, x plus y equals 8, and 2x plus 2y equals negative 3. That would be an example of two lines that are going to be parallel to each other. They look to be identical. They look to be a multiple of each other, but the difference is what they're set equal to. They're set equal to two different values, which means their y-intercepts will be different, won't they? Do you understand that? Okay. All right. So we're going to do each of these using substitution and elimination. We should get obviously the same answer, correct? If we're doing it either way. So let's use elimination. Yes? Because their slopes are going to be the same. In this case, I would get y equals negative x plus 8, right? In this one, I'm going to get 2y is equal to negative 2x minus 3, or y equals negative 1x minus 3 halves. So when the coefficients in front of the x and the y are exactly the same, and they're all written on the same side, they're parallel lines. What you need to look then is what are they equal to, because that will determine whether or not they are going to be a multiple of each other or going to be parallel to each other. Better? Okay. All right, elimination. Elimination means eliminating a variable. And remember, when we eliminate a variable, we want to have one variable being positive, the other one being negative in the second equation, with the coefficients the same. So I would say that which variable would be easier to eliminate? The x, right? Because I can multiply that second equation by what? Negative 2. I would use negative 2 because this already is a positive 2, and we want it to be negative 2 because we want that to totally drop out. So I need to see you telling me what you're multiplying through by. So the first equation stays the same, 2x plus 5y equals negative 5. And the next one becomes negative 2x. What am I going to write? Y equals. So don't forget to take that negative 2 to every single part of that equation. All right, we're going to combine these, and by elimination, those x's are dropping out. A 2x and a negative 2x drops out. Agreed? That leaves me with negative 1y is equal to negative 11, or y is equal to 11. How am I going to find a corresponding y? X. Plug it in where? Does it matter which equation? It really doesn't. Which one would be the easier one to plug it into? Because that's going to give me x right away, correct? So I know that x plus 3 times 11 equals 3. X plus 33 equals 3. So x is equal to negative 30. So what should my ordered pair be? Negative 30, comma 11. Okay, considering this has one solution, how would we name this? Would we name it as inconsistent, consistent and dependent, or consistent and independent? Consistent and independent, because it has one solution, right? So that would be consistent. So our definition of consistent and independent says we can, between the two lines, we get one solution. And we did. When we solved, we got one solution. We got an x and a y. So therefore, it is consistent and independent. These are two lines that are going to cross and have one common point where they're going to cross. Okay? Elaine? I can go either here or here. Yeah, I would go back to the original. All right, let's use, this was elimination. Let's do it with substitution. So substitution means take one variable and solve for it, and take that value and plug it into the first equation. Which equation do we, or which variable would be the easiest one to solve for? X where? Sure, I'm going to take this x plus 3y equals 3, and I'm going to let x equal negative 3y plus 3, yes? Does that make sense? And then I'm going to take that, and where do I plug it in? Yeah, don't plug it back into the original one. You're just going to get nothing. It's all going to cancel out. So now I'm going to take 2 times x, which is really minus 3y plus 3, add the 5y, and set it equal to negative 5. Negative 6y plus 6 plus 5y equals negative 5. Negative y equals negative 11, and we get the same answer that y is 11. We can take that y value and plug it into what we set x equal to. We know that x was supposed to equal negative 3y plus 3. So x will equal negative 3 times 11 plus 3, which gives me negative 33 plus 3, or negative 30. So in each case, I got negative 30 for my x value and 11 for my y. So the book will tell you, do it this way or do it this way, and if they don't tell you, then you can use whichever method you want. And like on a quiz or a test, I'll probably say, just to show me that you can do it either way, I'll have you, show that to me. Okay? Annie? You can do it in the original, but why would you want to go up to the original when I've already set it up for you to find x right here? Do you see what I'm saying? If you plug it back in the original, you've got to do more manipulation. All right, look at this next one. 3x minus 2y equals 2. 3x minus 2y equals 10. This portion is identical, but what it's equal to is not. So are these two lines that fall on top of each other, or are these two lines that are parallel? And if they are parallel, then what would we say that they should be? No solution, right? There's not, so, but we don't say no solution. We got to prove it. But what do we write? Inconsistent is what we should get. That's why in our head it's nice to know what we should get, right? So let's do elimination. And let's get rid of, it doesn't matter, the x or the y. I'm going to multiply the first one by negative 1. So that gives me, if I take this one times negative 1, I get negative 3x plus 2y equals negative 2. Positive 3x minus 2y equals 10. Everything cancels out, and we get 8. But that is an answer that makes absolutely no sense, right? Which is why we say that there is no solution, and we define it to be inconsistent. So let's say I don't see that it probably is going to give me no solution. And so I'm going to use elimination. And in my mind, I'm going to eliminate the x. So, but right now, both of them are positive. So I need to make one of the signs negative because the coefficients are both 3 in each case, right? So if I multiply it through by negative 1, that changes my first equation to a negative 3x so that they would eliminate when I stack them and add those two together. But that also changes then the signs of everything in that equation, right? And what happens is they all drop out. Okay, Elaine? Nope. Okay. If we were to do, this would not be one that I would suggest using substitution for because it's not easy to solve for either the x or the y without dealing with a fraction. Do you see that? So I personally think if you're going to use substitution, make it easy to solve for that specific variable without dealing with fractions because none of us like fractions. All right, let's look at this next one. What do we notice about this next one? Huh, Abigail? The bottom is a multiple of this. Okay, so the bottom is the top one multiplied, every term multiplied by what? Okay, so if one is a multiple of the other, then what kind of solution, what kind of lines do we have? We have lines that fall on top of each other because it's exactly the same line, isn't it? Okay, so let's look. When we get this, let's say we want to get rid of the x. And I multiply through by negative 2 on the top. That would leave me with negative 12x plus 10y equals negative 24. And 12x minus 10y equals positive 24. In this case, everything cancels out, including what it's equal to, correct? And this is a case that has infinitely many solutions. Yes, because it's something that makes sense. Everything's dropping out, so any value is going to work. There isn't one place where those lines are crossing. The lines are on top of each other, so every point on that line is going to be a solution for both of those equations versus only one point being a solution for both of those equations. Mm-hmm. You usually get 0 equals 0. Yeah. Elaine? Well, I was just going to do, so the answer to this, like the answer to this one was negative 3011, right? The answer to this one was no solution. The answer to this one is infinitely many, and then to define it, we would say what? Consistent and dependent, right? When we're trying to classify it. Yes? Well, if they're dependent of each or independent of each other, they're not relying on each other, and they just cross in one solution. When they're dependent on each other, we have one line, and the other one is falling directly on top of it. So the solutions of one depend on the solutions of the other, because there's not a single solution that works, but there's multiple solutions. Okay? Inconsistent are always going to be parallel lines because they will never meet ever and have a common solution. Okay? Does that clarify? All right. So here, let's have you guys try. Go up to the board. I'm going to give you some problems.